Okay, guys, we are up to section 1.4, problem solving with equations, day 2, which is on page 23. Let's do it. These problems are going to be a little bit more challenging than the previous ones, so just hold your hats. All right, and you're going to see some of Mr. K's amazing artistic ability on this first problem. So it says at 11:30 a.m., 2 planes. Let's go ahead and show off some of that artistic ability. There we go. Leaving Grand Rapids, 1 flying east. To me, looking at a map, we got a plane going that way. Then it says in the other, I got to duplicate that amazing masterpiece. There it is. Oh, yeah. All right. It's flying west. All right, so that's basically what I'm looking at. 2 planes flying in opposite directions, but here's a huge clue. They leave at 11:30 a.m. So in other words, they leave at the same time, opposite directions. Keep this formula in mind. Distance equals rate times time. We're going to piggyback that formula big time on this one. All right, having said that, the plane flying east is going 600 kilometers per hour. So I'm going to make that my R for the plane flying east. The other plane flying west is going 500. So I'm going to go ahead and say, all right, 500. All right. Now, as far as time goes, here's a clue. They left at the same time. So I can go ahead and call that T and T. I didn't use X because I want to let that remind me that that's a representation of time. And it says, at what time will they be 2,475 kilometers apart? So here's really the picture, 2,475 kilometers apart. In other words, this distance plus this distance has to add up to that. I'm going to write that over here. I'm going to go ahead and add these together too, because that's 600t plus 500t would be 1,100 t equals 2,475. So what I would do is take my calculator, handy dandy calculator, 1,100 divided by 2,475. No, I did that backwards. 2,475 divided by 1,100. That's 2.25. All right. So T equals 2.25. 2.25 what? Well, that's in terms of time. Think about this problem. It's 600 kilometers per what? Hour. So this is 2.25 hours. Now here's where these problems get a little trickier. It's the language of the question. At what time will they be 2,475 kilometers apart? If it said, how long did it take them to get this far apart, you'd be done. But that's not what they're asking. They're asking specifically what time will they be this far apart. Well, remember, they left at 11:30. They've been in the air for 2.25 hours, which is a different way of saying 2 hours and 15 minutes. That's what a quarter of an hour is 15 minutes. So I got to add this, or fast forward the clock, add 2 hours to that, and I would get 1:30, but I still need to add 15 minutes to that, and that would give me 1:45 p.m. All right. Now, scanning down in example 2 and example 3, you'll see that they're both coin problems. I'm going to leave this one for last. These coin problems are very similar to previous problems where you have the cost of an item times the number of them plus the cost of the other item times the number of them, and then that will equal total cost. Now this is something I showed on the previous lesson, but we're going to piggyback this, and I think it'll make sense to you guys. Cost is a little bit of a weird word for this, but you'll see what I'm talking about. Notice in this problem we have dimes and quarters. So for dimes, the cost or value of that would be 0.10. We'll talk about the number of them in a minute. Well, what's the value of a quarter? Well, that's 0.25. And then the total cost is total value, which would be $9. I'm just going to keep that as 9 if that's okay. Now we have a decision to make. It doesn't say anywhere in this problem that there's like 5 more quarters than dimes or 10 more dimes than quarters. It doesn't give us any clues, so we got to start somewhere. So I'm going to say, you know what? I'm just going to say there's X number of quarters, so like 10 quarters. If there was 10 quarters, then it'd be 50 dimes because there's a total of 60 coins. But I got to think mathematically. If I assign that a value of X, that means there has to be 60 minus X dimes. However many quarters I have, and I know there's 60 total coins, I'm going to subtract that from 60, and that's how many dimes I have. And now I got a pretty straightforward math problem. So I'm going to multiply right here. 10%, that's what that's basically saying, or 0.10 times 60 is 6. I got to distribute here, minus 0.10x, and then I got to go here, plus 0.25x equals 9. I'm going to subtract 6, subtract 6. At the same time, I'm going to add these like terms together. So I know these are gone. Add these together, I get 0.15x equals 3. I'm going to divide by 0.15, divide by 0.15, and now I got to get out my calculator again and say, okay, Mr. Calculator, help me out. 3 divided by 0.15 is 20. So I know x equals 20, but be careful on these problems. It says how many of each. So if x is 20, and I initially assigned x to be the number of quarters, that's my quarters. And if there's a total of 60 coins, that means there has to be 40 dimes. And there they are. All right. This next one that I want to jump into, just to get it started, I want to show this on the screen here, and then we'll flip it forward. But this one's different. If you scan the problem, you're going to notice the language says there's nickels, dimes, and quarters. So using this little somewhat of a formula, I know I've got 3 different types of coins. So I need to set up this relatively large equation. I'm going to start with nickels, 0.05, that's the value of a nickel. 0.10, value of a dime. And then a value of a quarter is 0.25. Now there's a little trick coming. That's pretty straightforward. Now the total value is 650. That's pretty easy to understand too. But now's where it gets interesting. There are 3 times as many nickels as dimes. Notice what comes second? Dimes. So I like to stay in the habit of assigning that x and then working backwards. There's 3 times as many nickels as dimes. So I know there's 3x nickels. Now how many quarters would be left? Well look, I got 3x nickels, x dimes, that's a total of 4x. That's a representation of the number of them. I got a total of 50 coins. So I didn't leave myself much room, but 50 minus 4x. And that's just a massive little math problem now. Multiply these together, I get 0.15x. Multiply that together, I get 0.10x. Distribute. And this is going to be a little bit weird because it doesn't come out all nice and clean. But I'm just going to go 50 times 0.25, and I get 12.5. So plus 12.5, and then what's 0.25 times 4? That'd be minus 1x, or just x, and equals 650. Now if I just add like terms, look what happens here. 0.15 and 0.10, that's 0.25x. That's gone, that's gone. 0.25x minus 1 would be negative 0.75x. So now these are gone, and now I got to get rid of 12.5. Subtract 12.5. And interestingly enough, negative 12.5 plus 6.5 would just give me a negative 6. Again, I got to resort to my handy dandy calculator. And so here we go. And when these problems come out nice and neat, you know you're on the right track. Oh, I forgot a negative right there. By the way, what did two negatives make? Positive. What is 6 divided by 0.75? 8. And you just know you're on the right track when that happens. And so I get x equals 8. But what did I just find? X. What is that? That's the number of dimes. The problem wants how many quarters are there. Well, I can just take x equals 8, pop it in this, and I should be done. 50 minus 4 times 8 is 50 minus 32, which is 18 quarters. Okay, with the few minutes we have left, we're going to tackle this last problem. Good news is this last problem is very similar. We're going to use this formula again, but it's talking about investing. But you'll see the connection. So some guy's got $6,000 to just spend, burning a hole in his pocket. He wants to invest it. Part of it's at 5% interest. I'd love to have you in class. We talk about interest, but for the sake of time, not happening. But then the other is 7% simple interest. It says if his annual interest income, that's money he makes as a result of investing $6,000, is $372. So how much did he invest? Well, see, the cost of an item is basically the value, which is a percent. 5% is 0.05. And then we don't know how we're going to assign the number of them yet, but we do know the value of this one is going to be 0.07. And he made $372 in 1 year by investing it. Doesn't sound like a ton of money, but he is making money. Now it says he invests $6,000, so this could be 4,000 and 2,000. This could be 1,000 and 5,000, or X and whatever's left, or 6,000 minus X. Now could I have put an X here and then put 6,000 minus X here? Yep, it'll work. So then I get 0.05X plus, right here, 0.07 times 6,000 is 420. Boy, I don't want to risk it. I think that's right, but 6,000 times 0.07. Yep, got it. 420 minus 0.07x equals $372. I'm going to add like terms. That's kind of weird, but negative 0.02x. Subtract 420, subtract 420, and that would be 28, and this would be negative 48. I'm going to divide by negative 0.02, divide by negative 0.02. Again, two negatives make a positive. Get out my calculator on these decimal problems. Don't want to risk it. 48 divided by 0.02, $2,400. What does that mean? It means he invested $2,400, notice, equals X at 5%. So that's at 5% interest. And then the remainder would be at 7%. So that would be $3,600 at 7% interest. That finishes off today's lesson, guys. 1-4, day 2. Have fun. Short and sweet assignment, but the problems are a little more challenging.